Welcome to the fourth video of this educational series where we will further define the definitions of low-level laser therapy. My name is Dr. Gary Graham and I want to thank you for joining us. All lasers utilize electromagnetic energy, which is comprised of the full spectrum of energy emitted from the sun and covers everything from radio waves to ionizing radiation, including all visible light waves, infrared waves, ultraviolet waves, and so on. The only difference between any of them is the wavelength and power density. Even though electromagnetic energy is everywhere, it is still poorly understood because they break all the rules of normal physics. But we do understand some basic properties of photons, or quanta. We know that photons are two-dimensional particles that carry electrical energy, but have no electrical charge. We also know that they have no mass. Yet they do have momentum and will move objects when they strike them. Which is why we have quantum physics, which is just the study of photons or quanta. We know that light travels in peaks and troughs similar to the waves of the ocean. And similar to waves in the ocean, these waves within photons are a unit of energy that travels within that photon. The wavelength of any given photon is the distance between one wave to the next. The wavelength can also be indicated as the frequency of that photon. This would be the number of waves that pass a given point every second and seldom used by anyone except quantum physicists and researchers. As these are long, complex numbers, the frequency of light should never be confused with the pulse frequency of therapy, which is the number of times that the laser light is turned on and off every second. This will be discussed in a later video titled Frequency Biomodulation. The amount of energy carried within each photon is proportional to its wavelength and amplitude or power density. The wavelength utilized in laser therapy are measured in nanometers or in billionths of a meter and is written as a small nm following the length of the wave. In low-level laser therapy, we utilize photons that have a wavelength of 630 nanometer to 635 nanometer. In infrared therapy, they use wavelengths greater than 760 nanometers. Next is the milliwatts of power, or the power density of the laser. A milliwatt is 1,000th of a watt, and indicated as a small m and capital W. The power density of some infrared lasers will be marked as full watts of power, written just as a large W. Each watt is equal to 1,000 milliwatts. To give you a better understanding of these numbers, a common 100-watt light bulb that you would use in your home puts out 100,000 milliwatts of power. Surgical cutting lasers start around 8,000 milliwatts, or 8 watts of power and up. The typical infrared lasers with a classification of Class 3B or a Class 4 run from about 500 milliwatts to 100,000 milliwatts of power. This is in contrast to a low-level laser, which is classified as a Class 3A laser and has a maximum power output of less than 5 milliwatts of power per each laser diode. The most important thing to remember about wavelengths is that every different wavelength has a different quality and unique effect on everything it strikes, especially living tissue. However, before we can talk about low-level laser therapy, we have to discuss light therapy. Why? Because most people think that's what we're here to talk about. However, they would be wrong. Light is the essence of the body. It's what we're made of. We require the full spectrum of electromagnetic energy that's emitted from the sun, including visible light, to remain healthy. Light therapy is something that we receive every day when we go outside. So how does this relate to the light therapy that we talk about today? Well, light therapy began by exposing your patient to the sun or full spectrum light after science discovered that patients that were deprived of sunlight suffered significant loss of health. Today's light or laser therapy is totally different and should never be called or even considered light therapy. Today's laser therapy does not replace natural sunlight. You could receive the typical laser therapy of today 24 hours a day forever and still get sick and die from lack of light. It is not light therapy. In fact, it's almost the opposite. Instead of utilizing full-spectrum natural light, we use a small fraction of man-made light, but that man-made light has very specific qualities. Even though today's laser therapy should never be called light therapy, the term light therapy has become a generic term for all light, laser, LED, and just about anything else you can think of that includes a light bulb, which is just one more reason for the mass confusion in our profession. Low-level laser therapy has been researched for over 60 years and contains tens of thousands of studies. Most were performed in the Soviet Union prior to their collapse or in Europe. There is no confusion, it is well documented, and it is well understood. However, Basford in 1993 stated, "Today the literature available on light therapy is not only confusing but contradictory." And today, it's even more confusing and more contradictory than it was in 1993. Unfortunately, that is due to medical political correctness and who is paying for the current research. So don't be fooled by accepting some research information without first asking a lot of common sense questions. And the best place to start is to follow the money. I had a professor tell me once that statistics never lie, but statisticians seldom tell the truth. And that's because they're usually hired to interpret statistics by someone with a predetermined conclusion. We stated that low-level laser therapy utilizes 630 to 635 nanometer wavelength laser light at less than 5 milliwatts of power because science has documented that this specific wavelength and power density has the potential to activate all known biological chromophores and have the ability to produce photobiomodulation like no other form or wavelength of light can. Biomodulation, when utilized within the physiological or natural doses of healthcare, is defined as changing the natural biochemical response of a cell or tissue within the normal range of its function, stimulating the cell's innate metabolism, thereby allowing the cell to heal itself. Photobiomodulation is performing biomodulation with photons. Next is the word laser. It's not really a word, but an acronym for light amplification by stimulated emission of radiation. The difference between laser light and all other forms of light, including LED light, is significant as laser light is coherent, meaning that every photon is in phase with the next, where LED lights are non-coherent. Why is this important? Years before science understood laser, Einstein theorized that the body produced coherent, today called laser, light as a method of internal cell-to-cell communication. If you want to communicate information to the body, then you have to use the system or maybe the language that the body understands. There's another basic confusion between LED and laser. Originally, lasers were made with tubes filled with different gases. Today, they're made with diodes because they are smaller, more durable, require much less power to operate, and they're able to be pulsed or turned on and off much faster than tube lasers, which means that all current electronic semiconductor lasers can also be considered LEDs, meaning light-emitting diodes, as the light of that laser is generated by a diode. However, there are many different types of diodes, including SLDs, meaning superluminescent diodes, that are used in headlights and room lights, and almost all the hundreds of little lights in your vehicle today is one form of LED or another. However, a laser diode is very unique as it produces coherent photons and is not the same as any other diode. So in therapy devices utilizing light, laser diodes produce true coherent laser light, where typical LEDs do not. There are three other properties that are associated with laser light. The first one is polarized, as all laser light is naturally polarized. Next, laser light can be precisely collimated into a fine point of light that can travel long distances and lose very little of its power density. There's a reason they call laser pointers, because no other form of light can be collimated or focused in this fashion. The last one shares the same properties as LED light, which is the ability to produce only one primary wavelength of light, and that is called monochromatic light, just meaning single color light. However, either one can also produce any combination or all colors of light. So why are these properties important? Well, there's three actions that light has on tissue. The first is reflection. When energy waves strike the skin or surface of any tissue, they will either pass through or be reflected off. This is a natural in vivo protection mechanism of the body. Since low-level laser therapy utilizes a visible wavelength, which is highly reflected off the skin and clothing, reflection is the first thing that we try to overcome. The energy's ability to pass through surface tissue is dependent on the collimation, coherency, polarization, wavelength, and power density. For low-level laser therapy, coherency and collimation are the two primary factors to prevent reflection of energy, and polarization also adds to this function of different tissues. However, infrared wavelengths are not reflected as well off the skin, so they naturally penetrate the skin much better than the visible wavelengths. So, it is the wavelength and power density that determines not only the reflection but also the depth of penetration of energy for infrared lasers. The second action of light on tissues is penetration. This is the distance the photons that were not reflected travel through tissue before being absorbed or transferred. For low-level laser therapy, penetration is minimal as it only requires penetration through the superficial tissues to reach the first living cells to activate a process called biological amplification. More on this in the next video. Therefore, deep penetration is something that is contraindicated for low-level laser therapy. However, for infrared laser therapy, penetration is again dependent on two factors: the wavelength and the power density. This is vital as this determines how deep the radiation will penetrate tissue before it's dissipated as heat, and how much heat or energy is present when it reaches the targeted tissue. This is defined as the joules of energy delivered to the target tissue. Since penetration and heat are contraindicated for low-level laser therapy, joules of energy have nothing to do with the proper dose of therapy when utilizing low-level lasers. The third effect of light on tissue is either absorption or energy transfer. When light quanta travel through tissue, some of the energy is absorbed by water or some organic molecule. Absorbed energy is always dissipated as heat, making penetration and absorption the key component of infrared laser therapy. Penetration delivers the energy to the deep targeted tissue, and absorption delivers the heat. But the power density of low-level laser therapy is low enough so that the body's thermal management systems are completely able to prevent any abnormal heating of the tissue being treated. The original and true definition of low-level laser therapy is that it will never raise the temperature of the tissue being treated by more than 1 degree centigrade, regardless of the time the therapy is utilized or the total number of joules of energy that were ultimately delivered. This makes the absorbed energy from low-level laser therapy so insignificant that it has no effect on the normal or the abnormal tissues being treated. Then there is energy transfer. As stated in the previous video, when a photon of the correct wavelength and power density strikes a matching chromophore, or light receptor, the photon's energy is transferred to the chromophore, and since a photon is only energy, it ceases to exist at that point. This produces no heat at all because the energy is transferred into a physiological function and not dissipated as heat. Since energy transfer is the therapeutic action of low-level laser therapy and heating tissue is contraindicated, the irradiation dose is not measured in joules of energy, but rather in photobiomodulation. Furthermore, higher-powered infrared radiation cannot be transferred to a chromophore for two specific reasons. We previously stated that transfer of photons to a chromophore is dependent on the wavelength and power density of the photon matching the chromophore. Just like the chromophores in your eyes, there are no mammalian biological chromophores that match or utilize infrared wavelengths. This is why infrared wavelengths are not visible to your eyes. Then a power density greater than 8 to 10 milliwatts is too high for chromophore activation, but will actually sedate chromophores. This is similar to looking at a bright light and being temporarily blinded. Too much light sedates the chromophores of the eyes, which means that photobiomodulation through activation of biological chromophores with infrared laser therapy can never occur. In our next video, we will conclude our discussion on the physiological effects of low-level laser therapy. As always, for further questions or information about laser pulsar system therapy products or any information of these videos, please contact me, Dr. Gary Graham, or anyone at these contacts. I want to thank you again for your time and interest in natural energy medicine.